This is a definite integral. So you know it's a definite integral when you've got bounds. So a lower bound of 3 and an upper bound of 7 on your integral symbol. So this is the definite integral of e to the 9x dx. So that integral symbol up in front and the dx in back, that's just telling you what to do to this stuff in the middle. So it's saying take the antiderivative of this equation and that x is the variable that I care about. This type of antiderivative problem, this is what I refer to as a special case antiderivative. Those are ones that you just have to have memorized, right? There's no way you're going to get to the answer unless you have it memorized. You had what I called special case derivatives when you were doing sine, cosine, tangent, your trig functions, natural logs, e's, all of those were special cases you just had to have memorized. So guess what? You have to memorize them going the other direction now as well. So we have to memorize undoing them. This is the special case for e. So if I have e to a number times x, this is the better way to memorize it when you've got a number in front of x. This is always going to work out to being 1 over whatever that number is, and then the e piece will stay the same. When I'm doing the definitions, I always put a plus c on there because I'm doing an indefinite example. But here, we won't have the plus c. So that's what we're looking at. We come and look at this right now, and to undo this, we need to follow that special case. So our a value is that 9. So we're going to get 1 over 9, and then the e piece stays the same, so e to the 9x. And then because we have a definite integral, we get this little evaluation bar, and we say evaluated from x equals 3 to x equals 7. And from there, what you'll do is you're going to come through and you're just going to go ahead and plug those values in. And we do what I call top minus bottom. So you're going to take the top value, plug it into that equation, and then you're going to subtract off the bottom value plugged into the same equation. And so what that looks like is we would get 1/9, and then this is going to be e to the 9, and then instead of x, we're going to plug in 7. That's our top value. And then minus, do the same thing with the bottom value plugged in. So we would come through and we would plug in our bottom value now. So 1/9 e to the 9, and then instead of x, we plug in 3, and then close that all up. From here, this is just something you're going to want to plug into your calculator. This thing actually turns out to be something crazy when all is said and done. This is going to be 2.54, and your calculator is probably going to use this like e symbol to the 26th. This is just scientific notation. So this would be 2.54 times 10 to the 26th. That would be the area between the curve and the x-axis, the net area between the curve and the x-axis, between 3 and 7 of that equation, e to the 9x. So definite integrals, we get out a definite answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.